Okay, so this is lesson 1 of acids and bases. We're just going to go over your acid and base reference sheet that you already have. I just made it bigger and I'm going to go over the whole thing real quick. So acids, basically they start with H, okay? So it says, for now it's sufficient to know that acids are compounds that give off hydrogen ions when dissolved in water, okay? That's pretty specific actually. It's not just... Okay, so acids generally take the form of H and then X, where X is some sort of anion, okay? It could be a monatomic anion or a polyatomic anion. Okay, we've previously named the compound HCl hydrogen chloride. Actually, we didn't do that. Somebody else did. But it's actually an acid, and we have to name it like an acid, such as HNO3. That's also an acid. So it says, when the anion ends with "ide," okay? So rule 1 here. When the anion ends with "ide," like chloride, okay? The acid name begins with the prefix hydro. The stem of the anion has the suffix "ic," and it is followed by the word acid. Thus, the HCl chloride, okay, dissolved in water is hydro, okay, and then the stem of the anion, which is chlor, and then the suffix "ic," and then the second word is acid, okay? Some of these are a little bit tricky, like anything that has sulfur in it or phosphorus, because the root of sulfide is sulfur. It's not sulf. So you wouldn't call this hydrosulfic acid. We call it hydrosulfuric acid. So that one's a little tricky, okay? Same thing with if you had H3P. Okay, the root of phosphorus is, well, if you were talking about an anion, the P would be phosphide, okay? The root of phosphide is phosphor. So this would be hydrophosphoric acid. Okay? All right. So I'm going to kind of cover that up as we go to the next thing. Okay. So when the anion ends with "ite," the acid name is the stem of the anion with the suffix "us," followed by the word acid. There is no hydro for these types, okay? No hydro in front. When the anion ends in "ate," the acid name is the stem of the anion with the suffix "ic." So "ite" gets replaced with "us," "ate" gets replaced with "ic." Both of them, the second word is acid. So H2SO3, SO3 is sulfite. So this is sulfur, because the root of sulfite is sulfur, and then "ite" is changed to us, acid. Okay, HNO3, NO3 is nitrate. So the root of nitrate is nitra, and we drop the "ate" and we add "ic." So this is nitric acid. That's it. Okay? Okay. And so, of course, there's 3 examples, and we've been through all of these examples. And that's how you name them. There are a few practice. At the bottom of the page, I just made the font bigger so that we could practice it. Okay. So it says name these compounds as acids. Okay. So we have H in front, we know that, and then ClO. Okay. So what is ClO? Okay, so you have your ion sheet. You can look it up on your ion sheet. That's not one you have to memorize. That is hypochlorite. So all we do is we keep the beginning, the hypochlor, we drop "ite," and we add "us." So this is chlor, us, and then the second word is acid. Okay, HCN. This one is special. You remember that this one is special. And it's not mentioned anywhere. I just mentioned it and told you, but it's special. So It's a ternary acid. So ternary acids are ones that have polyatomic ions in it, like this or like this. This one, though, notice it ends in "ide," cyanide. Okay, so cyanide. So if it ends in "ide," we start with hydro. The root of cyanide is cyan, so it'd be cyan. And then we add the suffix "ic," and then the second word is acid. So even though it's a binary or a ternary acid, we're naming it like it's a binary acid, like it only has hydrogen and one other monatomic ion. Okay, H3PO4. All right, so when you got to figure out, well, what is PO4? PO4 is phosphate. So the root of phosphate is phosphor because it's special. So phosphor, the suffix is "ic," and the second word is acid. Phosphoric acid. Okay, now if you had to go backwards and write the formulas from the names, okay, there we go. You just go in reverse. Okay, so if, as rule 3 shows, chloric acid, if it ends with "ic," but it doesn't have hydro in front, it must be hydrogen and chlorate. So you just write the formula for that and then balance the charges. If it starts with hydro, it's a binary acid, which means it's just H and one other monatomic ion. So in the case of, like, let's say if it was a combination of hydrogen and bromide ion, then it says it's hydrobromic, so it'd be H and then Br, and you just balance the charges. That's it. If it were called like phosphorus acid, oh, it's us. So, oh, and that's not spelled correctly. Oops. If it's us, if it ends with us, then it must be an ite. Phosphor is the root of phosph. So this is phosphite. So hydrogen and phosphite, and then you just balance the charges. That's it. So if we had chromic acid, notice there's no hydro, so it must be hydrogen and the polyatomic ion that used to be "ic," but now it ends in "ate." So chromate. So hydrogen and chromate. Chromate is CrO4. It has a -2 charge. Hydrogen has a +1 charge. So you need 2 hydrogens to balance out the chromate. Okay? Notice this one starts with hydro. And the root is iode and a suffix "ic," okay? Hydroiodic. So this means this is hydrogen, and if it starts with hydro, the root is just one nonmetal. That's iodine. So it's just I, and you balance the charges. Hydrogen is +1, iodide is -1. Hi, that's it. Chlorus, okay, so we see the us. That means it used to be ite. So this is chlorite. So it's hydrogen with chlorite. Chlorite is ClO2. Okay, and the charge on hydrogen is +1, chlorite is -1. It's already balanced. Okay, then we have perchloric. Okay, so we get rid of, there's no hydro in front, so I get rid of the "ic," and it's 8. So this is perchlorate. So hydrogen with perchlorate. Perchlorate, it's on your ion sheet. ClO4. Hydrogen is +1. Perchlorate is -1. It's already balanced. And that's your acid naming review.